Hey guys, so by request, I'll be doing a short tutorial on solving linear equations. Um, this request was made by a student whose name, well, he goes by the name of Jason. Shout out to you, Jason. You know who you are. All right, so just going to get straight into this tutorial here. So one of the first questions that's on this tutorial looks like this. And this question is asking you to find the value of that unknown z. Now, some of the first things you need to recall when you're trying to solve a linear equation, you need to identify which is your unknown in your equation. Remember, your unknown is that variable you're trying to find a numerical value for. Now, in this question, we see that there is only one variable, z. Now, second point to note when you are solving linear equations, the aim or your intention should always be to try your best to isolate that variable by itself on the left-hand side. So we are trying to aim towards getting something of the nature where we have z standing alone on the left-hand side and everything else on the right. Okay, so here are some steps we can try towards solving this linear equation. So the first thing I am going to do is perform a flip. Now in maths, a flip is where you just simply switch around your left hand and your right hand sides of your equation. So flipping, I would get z plus 33 is equal to 45. Now in a case like this, when you perform a flip, take note that there is no sign changes because you're simply rewriting your left-hand side as your right and your right-hand side as your left, which is a legal move in maths. Now we are going to go on towards solving our equation and we are going to find a value of z. So remember, once again, our intention is to isolate that variable that we are trying to find the value of. So in order to isolate our variable z, we need to make sure it stands alone. So what are some of the things we need to get rid of? Well, there's just one. And we need to get rid of plus 33, positive 33. In order to get rid of this, we simply subtract 33 from both sides to balance your equation, or as some students tend to learn it, we carry 33 across to your other side of your equal sign. In doing this, we end up getting simply z is equal to 45, subtract 33, and that gives us a value of 12. Just making sure on my calculator here, guys. Mistakes easily happen. Okay, so that's our first question we had on that tutorial sheet. Now we are going to move on towards doing the second question. So I'll erase this here. All right, and I'll keep that isolate variable on screen because this is going to be applicable to all questions. So moving on to our next question, we have 5n subtract 1 being equal to 4n. Now, once again, we want to isolate our variable, but in this question, we are seeing that we have the variable present on both sides of your equal sign. So what can we do? Well, if you have variables that are like terms, such as 5n and 4n, you can try your best to group them on your left-hand side. This will assist you in isolating that variable on the left. So let's go ahead and try that. So we are going to leave our 5n on the left. And now we are also going to transfer our 4n across our equal sign so that it becomes subtract 4n. Remember, when you carry terms across an equal sign, either you can say the sign changes, but in reality, you are simply subtracting 4n from both sides of your equation. We are going to bring down our equal sign. It's always nice to try your best to line up your equal signs one above the other. It makes things easier to see. And in the process of isolation, we also have that subtract 1 on our left, which we do not want. We do not want anything other than our variable present on our left. So in a similar move, we are actually going to transfer across our equal sign. On the left, we had -1. On the right, we are going to get +1. Well, it's the same as adding 1 to both sides of your equation. Simplifying this, we will get 5n subtract 4n gives us n. And on the right, we simply bring down our +1. And there you have it. N is equal to 1. So that was the second question. Now we are going to move on to our third question. Okay. Now, if you guys want to take a moment, you can pause this video and you can try these questions on your own as you get better and better. Now, here's a good one to remember, the distributive rule. When we have brackets, you want to remember that you need to distribute your number or your constant that's outside, and you need to multiply it by every single term within your brackets. In this case, we only have 2 terms. Multiplying, we will get 3 multiplied by x gives us 3x, and then 3 multiplied by 1 gives us 3. Please remember to check your signs, bring down your signs when necessary, and multiply signs. For example, if we were to have -3 in front here, this sign would change to a positive. Okay. On the right-hand side, we have a clear coast. So we are going to simply bring down our 12. Next step, we need to try to isolate our variable. Now we are seeing the variable present in our question is x, and we are being asked to solve for x. Now, in order to isolate or make that x stand alone by itself, we need to get rid of some things. One of the first things you would want to get rid of is your subtract 3. We are going to carry that across our equal sign. So we will bring down our 3x, we will rewrite our 12, and we will now have +3. Some students tend to write equals 15 in the same line, but I prefer to write line under line. Now, finally, we are one step closer to our final answer, and all we need to do is to separate that 3 from the x. Now, 3 here is being multiplied by x. So what we want to do essentially is divide both sides by 3. So we would have 3x divided by 3 is going to give us 15 divided by 3. This will always cancel. And on your right-hand side, we end up getting 5. Therefore, x is equal to 5. I want to highlight this line once again. Whenever you have a situation taking place like this, where you have your variable being multiplied by some constant value, it's usually the last thing you want to remove or separate during the process of isolation. All right, with that said, let's move on to another question. All right, I'm going to scroll up a bit here just so we can kind of leave our heading. All right, so our next question is 2x plus 4 being equal to 3x, subtract 5, subtract 5. And we are being asked to solve for the value of x. Now, once again, during the process of isolation, you would notice that we have variables present on both sides. So you want to bring them together. Bringing them together, you would get 2x, and carrying across this, because it's a positive 3x on one side. When you carry it across your equal sign, it becomes subtract 3x, or essentially subtracting 3x from both sides of your equation, for those of you who do correctly learn it like that. And then finally, on our right-hand side, we are going to bring down our negative 5, which was untouched. And in the same step, we are actually going to transfer our positive 4 from the left, and we are going to carry it to our right-hand side such that it becomes subtract 4. Now, all that's left is to simplify. 2x subtract 3x gives us negative 1x, or just negative x. And negative 5 subtract 4 gives us negative 9. Therefore, you can cancel off your negative signs and end up with x being equal to 9. Let's move on to another question. Ooh, I'm enjoying erasing this whiteboard today. All right, so this next question rather, is a little bit of a fraction type question. I would suggest those of you who have issues with questions like these, you practice some addition and subtraction of fractions. Okay, so this question tends to be scary. And why is it scary? Because it looks complicated. But you see, looks can be deceiving when it comes to algebra. Once you know your rules, all you need to do is take your time. One of the first things I like to do when I see algebraic equations that we have to solve and they are of a fraction form, I always like to make sure every single term is written in a fraction form. So the first thing I am actually going to do is change that 3 to 3 over 1. Now I'm satisfied. When you're adding fractions, what you do is you draw your LCM and you find your common denominator. In this case, the LCM of 3 and 2, that's 6. And then the next step you usually take when you're adding or subtracting fractions is division. You would say, how many times can 3 be divided or go into 6? 3 goes into 6 2 times, and you rewrite what was originally on your numerator. Plus, how many times does 2 go into 6? 3 times. And you rewrite your original numerator. Now, there's an easier way to remember this, and it's called crossing, whereby some students observe their denominators and they find their LCM. However, what they do to get their numerator involves a simple process of cross multiplication, whereby you take your denominator of one of your fractions and you multiply by the numerator of the other. That's how they ended up getting 2 multiplied by 2x minus 3. Ah, looks easy now, doesn't it? Similarly, you cross your denominator of your remaining fraction and you multiply by your numerator of the opposite fraction. Hence, 3 multiplied by 5 subtract x. And that's a useful little trick that is very well used and with very, what's the word I'm looking for? It's highly used by students who have issues, you know, adding and subtracting fractions and stuff like that. Now, on the right-hand side of our equation, we are going to continue just leaving that fractionated form. And what we want to do is clean up our numerator. Now, in order to clean up our numerator here, we just simply need to expand our brackets. So you are going to have 2 being multiplied by 2x. That gives us 4x. Subtract 2 multiplied by 3. That gives us 6. Now we are going to attempt to expand our second brackets. So we're bringing down that positive sign between those two terms. And we have 3 multiplied by 5, giving us 15. And then we are going to bring down our sign because there's going to be no sign change. We have a positive 3 outside. We're going to multiply that positive 3 by x to get 3x. And we rewrite what's left on the right-hand side. Notice we have not touched it as yet. You want to clean up your fraction as much as possible. Now we are going to group like terms. So we have 4x and we also have 4x and we also have subtract 3x. Now a common mistake students make here is that they will see 4x and they will add it to 3x, where they completely ignore the sign in front of your term. Take note that the sign that is important to a term is always the one that's written in front. So if you were to move a term around, always move it around with the sign that's in front of it. So grouping our like terms together, you will get 4x subtract 3x just gives us x. And then finally, we have -6 being added to 15. If you work that out in your calculator, that is going to give you +9. I think I'll change my color here. And I'm going to decrease my line. Lovely. And we are going to bring down our 3/1. Now take your time, look at that question. It has come down from quite a big equation to a simplified version. Now that we have reached a form where the numerator is as simplified as possible and there's nothing left to do, we are going to cross multiply. And this is something that we always do when we have a fractionated form on both sides of your equation. You always cross multiply, and you can choose to cross multiply in any order, but always make sure the order you choose is one where your variable is isolated on the left-hand side. So I'm going to cross multiply x plus 9 with 1. And on my right-hand side, I will cross multiply by 6 by 3. That gives us x plus 9 is equal to 18. And finally, x is equal to 18, subtract 9. So x has finally worked out to be a value of 9. I'm going to clear my page and move on to our next question. All right, our next question actually involves another fractionated form. So we have 3 all over 7x subtract 1 plus 1 over x being equal to 0. So the first thing we are going to do is, well, 0, we can't exactly make a fraction by placing it over 1. That doesn't make sense. It will still be equal to 0. So in a case like this, we're going to focus on our left-hand side, and we're going to try our best to form that LCM. Now, our LCM for this will simply be x multiplied by 7x minus 1. And to get the numerator, we are going to go ahead and perform our cross. So our cross will take place in this order. We are going to get on the top 3 multiplied by x plus, and then you're going to cross this way. Be careful you cross with the wrong fraction first. You're supposed to start with your leading diagonal. Always start from here. So crossing on to our last part is going to give us 7x subtract 1 multiplied by 1 being equal to 0. Let's clean up that numerator. So on the numerator, we have, just rewriting my denominator there. On the numerator, we have 3x plus 7x subtract 1. Because that bracket's being distributed with a 1 outside will just simply give us 7x subtract 1. Now on the numerator, on screen, I'm actually going to clean these two terms up. We have 3x plus 7x here, and that's simply equal to 10x. So actually what I'm going to do is I'm just going to erase this here, and I am actually going to write 10. Okay guys, so finally, but not lastly, we do have to perform a cross multiplication because we do have a fraction on our left. Even though we don't exactly have a fraction on our right, we still can perform a cross. So the cross will happen in such a way where we are going to multiply our denominator in a diagonal way. And what's going to happen is that we're going to get 10x subtract 1 is going to be equal to 0. Do you guys see that? Take a moment and understand. You see 0 could be written as 0 over 1, so that if you were to cross this way, you would get 10x subtract 1 multiplied by 1. Moving forward, now we are left with an equation which is solvable. So this becomes, we're going to carry that 1 on your right hand side, and then finally we're going to divide both sides by 10. So this becomes 10x over 10 is equal to 1 over 10. And that will always cancel. So our answer for x simply equal to 1 over 10. So now I'm going to clear my screen again. And I'm going to show you 2 bonus questions. These are not essentially questions where you're solving, but rather these questions are making a particular variable the subject of the formula. So making a variable the subject of the formula. I like to title it SOF for short. All right, guys, so let's just say we had an equation containing several variables, 6r, and they wanted to make, let's just say b, the subject of the formula, which means we need to get b on the left-hand side of our equation and isolate it so that it stands by itself. Now, doing this, one of the first things I'd like to do is flip. So I am choosing to flip my sides because I can see if I flip my sides, the variable that I want to isolate is already on my left. And now I'm going to carry everything else across to the right-hand side. Doing so, the first thing I am going to carry across is that 6r, such that it becomes a subtract 6r. And then finally, I notice that attached to the variable I am trying to isolate, I have a constant 2, and I also have a variable r. So what I'm going to do is I'm going to divide by 2r on both sides. Dividing by 2r on both sides causes my 2's to cancel as well as my r's on the left, so that I end up getting the required isolated variable standing alone by itself. And then we get our answer on the right. Take your time, replay if you need to, take it very easy and breathe. I'm going to do one more example from this tutorial that this student sent to me. Okay, so last one. What if we have m being equal to w over 4 subtract r over, is that 74? I think it looks like 74. And this question is asking us to make r the subject of the formula. So we are going to isolate that r. Once again, one of the first moves I would make is a flip so that I can get, actually no, I'm not going to make a flip because I'm seeing that we have a negative sign here in front of our r. So if I were to flip it, that sign would remain. But if I move my entire term across alone, it becomes positive. So these are some of the things you need to see. You really need to visualize it happening before it does when you make moves. But nothing is wrong if you choose to flip first. You will still end up with the correct answer. And that's the thing about algebra. You can approach your answer in so many different ways. Okay, so first thing I'm going to do is I'm going to leave that m, sorry. I'm going to leave my m alone where it is, and I'm going to bring across my term r on 74, or rather add r on 74 to both sides, and I will end up with this. So all I did was carry this term across my equal sign. Do you see it? Great. And then we're almost there. It looks complicated, but this one was actually pretty easy. Now we need to isolate, so we need to get rid of that m there. So we are simply going to carry or move our m to the right-hand side. So it was positive on this side, so we subtract on the opposite. Now, all we have left to get rid of is this division by 74. Now, in order to get rid of that, we need to consider what is happening there. Now, how can we get rid of that 74? We can multiply both sides by 74. So on the left, if you are dividing by 74, to get rid of it, you simply carry across your 74 in a multiplicative process, and you make sure that you multiply every single thing on your right hand side by 74. If you were to write something that looks like this would be wrong, because writing a statement like this says that you are multiplying your 74 only by your W on 4, and you have forgotten to multiply by your negative M. So make sure, if you have a huge chunk, such as we do in this question, that you always incorporate brackets before carrying across a denominator to your right-hand side. All right, so this is your answer for making R the subject of the formula in this question. So for all of you out there who benefited from looking at this tutorial, I hope you guys just simply leave a comment down below in any of my videos, and you can send me your questions and ask me to do tutorial sessions on a particular topic or whatever you want to see, and I will be sure to respond to you guys. So all the best, and see you guys next time. Bye.